in non-uniform electric field, you know force, conservative force formula, you know it already. So force, what is the formula? Minus dou u by dou r, right? So you know potential energy, what is the formula now? U is equals to minus Pe cos theta. So substitute it now, therefore F is equals to minus of minus plus. Dipole moment we are not going to change onto this one now, P and theta, therefore cos theta into dE by dr or dou E by dou r. So this it will be your force acting on a dipole due to non-uniform electric field. Here dE by dr is nothing but electric field is changing with respect to the distance here now. So if you want to write down in terms of dot product now, therefore F so is equals to, therefore P dot, right. So here you can write it based on this angle onto this, clear. So F is equals to P into cos theta into dE by dr, right. Let us see one important concept now. What will be the force acting between the two dipoles? Very, very important concept now. Suppose there are two dipoles are there. Let us take one like a question here now. So question, there is a one dipole is there. This is lying in the same axis onto this. Let us take therefore here there is a one dipole is there, short dipole P1 no, and another one more dipole is there, therefore it will be the P2 dipole moment. So the distance between the centers no, it is given as like a r, clear. So this is nothing but a dipole-dipole interaction onto this, right. So we want to calculate what will be the force acting on the second dipole due to the first dipole. See what is the force acting on the second dipole now, how to calculate it now. Force acting on the second dipole, it will be equal to this dipole moment P2 cos 0, right. So therefore what will happen now, here cos 0, now this is the dipole and this is creating the electric field at this point. That means this P1 is creating the electric field. That means so electric field due to, therefore d by dr, electric field due to this P1, how much now, k into P1 by r cube, axial line no 2, clear. So therefore you can rewrite it as cos 0 is 1 no, therefore 2k into P1 P2 into differentiation of this one no, therefore so minus 3, right, into r to the power of minus 3 minus 1, clear. So what you will get it now, minus 6k P1 P2 divided by r to the power of 4, this is your force, clear. So this side is negative, positive, I mean negative and positive, therefore here this is negative, positive, therefore negative, positive, therefore attraction force it will be there now, attraction, correct. So that's why it is said to be like a negative onto this. Here force between the two dipoles now is inversely proportional to the r power 4, very, very important now, right. Force due to these two dipoles no, it is inversely proportional to the r to the power of 4. So force between the 2 point charges is how much no, 2 point charges. So what you can write it now, force between charges no, it is inversely proportional to the square of the distance. Here charge and dipole we'll do this one now, okay. So it is inversely proportional to the cube of the distance. Here dipole and dipole force is inversely proportional to the r to the power of 4 now, very, very important concept now. So be careful on this point, right. Force between the 2 point charges is inversely proportional to the square of the distance. Force between the dipole and charge is nothing but r cube. Force between the dipole and dipole is nothing but r to the power of 4. I said I will do this question no. So now, so we'll see there is a one dipole is there now. Let us see this one now. There is a one dipole is there, minus q, and therefore it will be the plus q. So therefore we want to calculate that some charge is there now, therefore at certain distance. So q is the charge is there. So what is the dipole moment here now? Dipole moment is like this. What will be the electric field along the equatorial line now? Electric field is in this direction now, clear. So electric field, so therefore force acting on this one is how much now? So electric field into q, correct. Electric field due to this dipole is how much now? Electric field now, so k into p into q by therefore r cube. This is the force acting on the charge. So this is the force acting on the charge, no, that much amount of force is acting on the dipole, no. Therefore, like a Newton's laws, no, action and reaction, no, this is the force acting on the charge, the same amount of force is acting on the dipole. So therefore, force acting on the dipole is inversely proportional to R cube. Just now I said, no. So force between the dipole and charge is nothing but inversely proportional to R cube. Clear? So in this way, for non-uniform electric field also, therefore you can calculate it, no, by using this formula, F is equals to minus, therefore that is dou U by, therefore dou R. So you can use potential energy is nothing but minus P dot E. Clear?